Hello and welcome to Real-Time Innovation's e-learning online training program. My name is Rose Wallen and I'm a Principal Applications Engineer at RTI. And today we're going to be talking a bit about debugging your Connext system. So the list of training modules that we're going to be discussing for this topic. The first module we're going to talk about is what to do if you get no data at all. So you've created your publishing application and your subscribing application, or perhaps something more complex, and you see that you receive no data. The second module we're going to talk about is what to do if you see that you get some data, but you're also losing some. And perhaps you've turned on reliability and you're wondering why your data is not actually all being received. Module number 3 is how to debug complex protocol problems. So if you are seeing that something very strange is happening and you think that maybe you can drill down all the way to the level of the protocol and figure out what's going on, this will give you some guidance into how to do that. Module number 4 describes how to handle more difficult problems. Perhaps something strange is happening when you create your Connext objects and you'd like to know what's going wrong. This will talk about how to turn on logging to see what is happening. And module number 5 describes where to find additional help. So if you decide that the problems you're debugging really require outside help, where can you go and find that help? Module number 1, I get no data at all. So in this module, what you're going to learn is how to debug the problem of getting no data at all. And the prerequisites for this module include having a basic understanding of publish-subscribe and the RTI Connext objects that you're creating, and a basic understanding of discovery inside of Connext. So what to do if no data arrives? The first thing to know is that communication problems can happen at many different layers. This could be a problem in your application itself. This could be a problem in the middleware layer, which is where RTI Connext sits. It could be a problem at the level of the operating system or drivers, or it could be an actual network problem. And so debugging what the real problem is can take multiple steps. The general approach to this, if your application is receiving no data, well, the first step to take is to just double check that neither the sending machine nor the receiving machine has a firewall turned on. This is the most common cause that we see for data not being received, is that a firewall on one side or the other is blocking either the discovery traffic or the user traffic or both. Now, the second thing you want to do after turning off the firewall or checking that the firewall is off is to see if you can actually ping the machine that you're talking to. This sounds really simple, but we've seen this more than once, that a network cable accidentally got disconnected or something happened so you can't actually reach that machine. Now, I will usually do this after turning off the firewall because a lot of times the firewall will block Connext traffic but will not block pings. So you may see that a ping goes through, but the firewall is still blocking the rest of the Connext traffic. So I usually turn off the firewall first. Okay, so if you can't ping it, then you recognize that the problem is somewhere below Connext. If you can ping it, usually the next step is to test with either the RTI DDS spy tool or the RTI DDS ping tool, and we'll talk about both of those. So starting out with RTI DDS Spy. RTI DDS Spy is a tool for testing connectivity and for very simple data display. So what this does is this separates out connectivity problems from some of the problems with application logic. So the RTI DDS spy tool, this is a command line tool that will discover all of your applications with data writers. It will print out to the console this discovery information, and it will also print out data as it arrives. So we say this is separating out connectivity problems from application logic problems for two reasons. One reason is that this is a very simple application that we know will correctly receive all data. The other reason is because this tool sets up the quality of service by itself automatically, so it is guaranteed to match with your writers. Of course, what this doesn't do is this does not show if there's a problem where your writing application simply isn't writing. So this reduces the complexity on the receiving side, but not on the sending side. How to use RTI DDS Spy. From the RTI launcher, click on the Utilities tab, and you'll see RTI DDS Spy at the bottom. If you click on this, you see a dialog that has various options for how to run RTI DDS Spy. The first one is the domain ID. So depending on the domain that your application is in, you may want to change this. You also have the option for whether or not you want Spy to actually print out the values of the data as it's arriving. You also have a topic filter and a type filter, where you can use a regular expression to specify which topics and or which data types you are interested in seeing data updates for. You also have a time-based filter, so if you do not want to see updates as quickly as they're happening, you can specify that. And you have the option to specify which transport or transports you want Spy to use. I'm going to start out with everything at the default. Right now, I am currently running a Hello World application from a command prompt. So here I'm going to run Spy. The first thing you see when you start up Spy is the discovery information. You see here that there is a uppercase W. This indicates that Spy has discovered a new data writer. You can also tell that it's new because there's a plus sign next to the new sample indicator. If this had gone away, you would see a minus sign here to indicate that Spy has detected a data writer has gone away. We can also see here the topic of the data writer, so in this case it's example hello message, and the data type, which is hello message. And after we see the indication that Spy has discovered the data writer, we see the various data samples arriving. Now I'm going to shut down Spy and start it again with the print sample option enabled. So here I run Spy, and I see first the discovery information. Spy will always show you the discovery information for everything that it discovers, regardless of whether you have a type or topic filter on. You'll see everything, writers and readers. You can see here that my Hello World has a single field called message, and it's printing out the values inside this message, which is a string. Now with Spy, this is an excellent tool for detecting, first of all, that discovery has completed. As I showed you, we discovered this writer here, and then that data is actually being sent. So perhaps in your application, the actual problem is that your quality of service are incompatible with the quality of service on the other side. Spy can help you detect that. RTI DDS Ping. RTI DDS Ping is another command line tool that you can use to test for basic connectivity problems. RTI DDS Ping isolates you even more from application logic problems because RTI DDS Ping contains either a publisher or a subscriber. And so you can set up a connection with the publisher on one side and the subscriber on the other, and you know that the logic for publishing and subscribing is well known and well tested. So you can create this connection and simply check to see if discovery is completing and if data is being received. RTI DDS ping is available on the launcher from the same tab as RTI DDS SPI. It's on the Utilities tab. So if I click on RTI DDS ping, I have a variety of options. And what I'm going to do here is I'm going to create one application that is publishing and create another one that is subscribing. So here I'm going to create my publisher application in ping. And I'm going to create a subscriber application in ping. And you will see here that the subscriber application is receiving data. So this is an excellent way to detect whether discovery has completed. So similarly to SPI, this will tell you that discovery has completed. But this also will show you that data can be sent. So not just discovery, but also user data can be sent across the network. This is an interesting thing to know because, for example, if you have a firewall or perhaps your router or switch is blocking certain ports, you may find that discovery completes, but you get no data. So this will help indicate that. You'll see that you've discovered something, but perhaps you get no data, and then you have to look further and see if something is going wrong on your network. So how do you debug with RTI DDS SPI and RTI DDS ping? So in this case, we still have the scenario that your application is receiving no data. One of the first things you can check is to see if SPI or ping works on that same receiving machine. If SPI works or if ping works correctly, your next steps will be to test for quality of service incompatibilities or test your logic in the receiving application to ensure that you have, for example, actually created a data reader and that data reader is listening to data either using a listener or a wait set or polling. So if SPI works correctly on the receiving machine, the next step is to look for incompatible QoS or your receiving logic. Now, if SPI does not work on the receiving machine, the next step you can do is run SPI and ping on the sending machine. So in this case, if you are perhaps running your application on a server somewhere, and now you run SPI on that same server, and you see that SPI does get data there, where it did not get data on the receiving machine, you can look for certain types of problems that may be happening on your network. Probably the most common one that you would see is that your network does not allow multicast. If you recall from the Discovery section, Discovery uses multicast by default. So while it isn't required, if you have not changed your initial peers or any of your other settings, Discovery is going to be relying on multicast working on your network. The next thing to check, if you determine that multicast is in fact enabled, is you need to check if there are any problems routing on the network. If there are problems routing between your sender and receiver machine, then you're going to have to fix those before you can continue. If SPI or ping does not work on the sending machine, the next step is to test with RTI Analyzer and to also test the logic in the sending application. Perhaps it is not actually sending any data, or perhaps it is not actually creating a data writer when you think it is. RTI Analyzer. So the next step to discovering what might be wrong with your application if you're receiving no data at all is to use the RTI Analyzer tool to look for either strange discovery problems or quality of service problems. So to start out, let me give you some information on what you might see, and then I'll give a demonstration of RTI Analyzer. So the first thing that you might see if there's a connectivity problem is you may see no domain participants at all. If that's the case, then what you should check is you should check to see if your initial peers are set correctly. By default, initial peers includes a multicast address, and so if multicast is working on your network, you should be seeing domain participants. However, if multicast is not working correctly, or if you've chosen to disable it, then you may have to set up your initial peers. The other thing to check is for your transport settings. It's possible that you have changed your transport settings in your applications and either not changed them everywhere or forgotten to set them in Analyzer. So if you see no domain participants, it could be a problem with your initial peers or it could be a problem with your transport settings. The next thing you might see in Analyzer is you might see a domain participant but no readers or writers. If you see this can indicate one of several other problems. The first one to be aware of is that you could see this if you have more than 4 networking interfaces on the remote machine that you're trying to communicate with. The RTPS2 protocol supports only up to 4 interfaces that are announced as part of discovery. So if you have, let's say, 6 or 8 interfaces, and the first 4 of those cannot be reached by your local application, what happens? Well, what happens is that participant discovery completes normally. Your domain participants announce to the multicast address and they discover each other. But once that happens, when they send their announcements, those announcements include a list of 4 addresses. And if those 4 addresses are not actually reachable, and this typically happens if you have a lot of virtual machines, for example, if these are not reachable, then discovery doesn't complete. You end up with partial discovery. And you can see this in Analyzer because you will see domain participants but no readers or writers. Another thing this can indicate is firewall problems. This is actually the most common cause, but I already talked about the fact that you should have turned your firewall off as the first step toward finding potential problems. The next thing that RTI Analyzer can show you is quality of service mismatches. And I'll be showing you how you can see this in Analyzer in just a moment. To open up RTI Analyzer, go to the Tools panel of the launcher. Click on Analyzer. When RTI Analyzer opens for the first time, the first thing you'll have to do is set up the initial settings for the domain that you're interested in. When RTI Analyzer starts up for the first time, it may display a help page. I've run Analyzer before, so that does not display for me. You can close that help page, and when you do, you will see this view. The first thing you need to do when running Analyzer for the first time is to configure the domain that you're going to be joining. So you can click on this configure icon, and it will pop up a dialog that will let you configure the initial peers and the transport settings for the domain that you're interested in. So here I'm interested in joining domain 0, and I'm going to leave everything default. However, if you have changed the transport settings for your actual application, you need to ensure that Analyzer is using the same settings. You can do that either by changing the settings here, or by allowing Analyzer to use your QoS file and your QoS profile so that it has the identical transport settings that your application does. Now I'm going to click on Start, and Analyzer is going to show me what's happening in this DDS network. So Analyzer can be described as a tool that allows you to visualize discovery. This means that Analyzer itself is creating a domain participant, and it's simply displaying for you all of the remote domain participants, remote data writers, and remote data readers that it has discovered. So here in my system, in domain 0, I have a single host, and I'm running 2 copies of the shapes demo, one with a writer in it and one with a reader in it. If I click on the reader, I can find information about this reader, including the topic that it's reading, that data type that it's reading, and some of its quality of service. Now, Analyzer is showing you a subset of the total quality of service available for this data reader. The reason why it does this is because this is the quality of service that's actually exchanged as part of discovery. There's additional quality of service, such as the resource limits or the history, that is not used as part of discovery, and it's not used as part of the matching process to see if writers and readers are compatible with each other. That quality of service is purely local, and so it is not sent as part of discovery, and Analyzer cannot display it. We'll be looking a little bit later at the monitor tool, which can give more in-depth information about all of the quality of service for any particular reader, writer, publisher, subscriber, etc. But for now, it's good to know that you can see a subset of the quality of service here in Analyzer. Now, if I open up my Shapes demo applications, I've got a publisher and a subscriber of square data. And what's happening right here is I'm showing you a scenario where I'm receiving no data at all. And the question is, why is this happening? Well, the first thing I can see is that I do in fact discover everything in Analyzer. This indicates that probably discovery is working correctly. If I saw only the domain participants here and no readers and writers, it could indicate one of the problems I described earlier, such as a firewall blocking some of the traffic, or having more than 4 enabled network interfaces on your system. So here I say probably discovery is happening correctly. So I've ruled out certain types of network problems and configuration problems. The next step is to start to look for application problems. And one of the most common application problems in DDS is incompatible QoS. The Analyzer tool helps you to easily diagnose this by using match analysis of all the readers and writers that Analyzer has discovered. I can do this here by clicking on the Match Analysis tab, and you can see here that it's going to match all of the entities, so all writers and all readers. And I can click on Perform Match Analysis, and immediately I can see that there is a problem in the system. So my match analysis is showing up as pink, indicating that there is a problem. And I can see there's one topic, one writer, and one reader, and a single mismatch. So if I open this up and drill down, I can see that my topic is square. I've got a writer and a reader for this. Now if I drill down all the way to the bottom level and I click on the reader, I can actually see all of the quality of service between the writer and reader and whether they are compatible or not. So here I can see that I do have an incompatibility, and the problem is that ownership is shared on the writer and exclusive on the reader. This quality of service has to be the same on both the writer and the reader, and since it is not the same, it is incompatible, and the writer and reader are not communicating. This particular information, that you have incompatible QoS, is also available in your application. You can discover this either by installing a listener on your writer or reader, or using a wait set, or simply checking if your writer or reader have discovered somebody that they are incompatible with. However, if you do not want to put that logic in your application, you can check at runtime using the Analyzer tool. So here I see my writer and reader are incompatible. So if I click on OK, I'm now going to delete my reader. And you can see that this reader disappears from Analyzer. And I'm going to create a new reader that it does not have exclusive ownership turned on. So now this will be compatible with the writer. And here I can see that this new reader does receive data. So here I have my writer and my reader, and the reader is receiving correctly. So in Analyzer, if I perform a new match analysis, I can see now this match analysis appears green, and that my writer and reader are entirely compatible. A little bit more information that you can find out inside of Analyzer that we haven't talked about yet. I'm going to go back to the Entity Info tab, and I talked about the fact that quality of service is available as part of what Analyzer can display, and that this quality of service is what is sent during discovery. Some of the other information that Analyzer can display includes the status of your entities, whether they are active or not, includes whether you have sent any custom user data as a part of discovery, and it will also tell you what your data type is. This last part is interesting because your data type information is not always available all the time. Your data type information is available as long as it isn't too large. And if you have data information, or type code as we call it, that is too large and it is not sent as part of discovery, this may cause some of our tools to not work correctly. For example, the recorder tool will need additional configuration, or the routing service tool will require additional configuration in order to work properly if it does not know the type of your data. One way to know if your data type information or type code was actually sent as part of discovery or not is using Analyzer. If this information appears blank, it means that your type information was not sent because it was too large. If this is the case, there's additional configuration you can do, and there's more information on our website for how to configure the type code information. And now to summarize the typical causes of receiving no data at all. The first typical causes include a lot of typical network problems. This could include a problem with the physical connection, so a wire becoming disconnected, or even sometimes using a crossover cable when you intended to use a normal Ethernet cable can cause disconnections or no data to be sent. Another common network problem would just be a problem with the network routing. Another common network problem is having multicast disabled on one or more of your switches or routers. And in fact, to even go a little bit further, if you are traversing more than one router, then multicast will not traverse more than one router by default with our default QoS. The other typical causes include common OS problems, such as a firewall being on and blocking RTI traffic. And some additional typical causes. The most common RTI problems include having more than 4 network interfaces enabled on your machine. Because RTI supports a maximum of 4, and in fact, the standard RTPS2 protocol supports a maximum of 4 interfaces that get announced as part of discovery. Some of the other typical causes include application or configuration problems, such as having an incorrect initial peers environment variable. You may have a wrong IP address in your initial peers, or you may, if you're using unicast, not be announcing to enough ports on the remote machine. So you may want to review in the user manual the section on discovery and initial peers, But to reiterate some of what it describes, when your participant is sending announcements to a unicast address, by default, if you don't specify how many participants it should contact, it's only going to contact the participants at 0 through 3 on that remote machine. If you recall from the discovery section, the participant ID is used to calculate the port that it's contacting. For multicast, all participants can share the same port, but for unicast, they must open up a different port for each domain participant you create. So because of this, your local participant, when it sends announcements, it has to try and contact a certain set of ports at the unicast address. And by default, it's going to try and contact only 4 ports, those associated with participants 0 through 3. The next typical application or configuration problem is incompatible QoS. This is one of the most common problems, and you can diagnose it quite easily using Analyzer, as we saw before. A few other typical problems include a sending application not actually writing data. That can happen sometimes. And you can isolate this problem by testing with SPI and RTI DDS ping, actually, to see if other applications are able to write data or not. Other typical problems also include the receiving application not actually installing a listener or setting the mask incorrectly so that the listener does not get notified of events. You may also have a receiving application that is failing to poll for data, or a receiving application that is not correctly creating a wait set, or not setting the conditions on the wait set for it to actually wake up when data becomes available. So all of these can be isolated using the tools such as Analyzer, RTI DDS SPI, and RTI DDS ping. So now just to reiterate what we've covered in Module 1. We've started with the scenario that you are receiving no data at all. And we've taken a look at some of the typical causes of this. Everything from low-level network problems to RTI problems to configuration problems. So this should give you a good idea of how to start to methodically analyze the scenario when you have no data at all. We also talked about the basic tools for analyzing this, including RTI DDS SPI, RTI DDS ping, and RTI DDS Analyzer.
Thank you for watching this portion of RTI's online training, focused on RTI Connext DDS. We'd also like to remind you that there are additional resources located on our eLearning webpage at www.rti.com/elearning. We also invite you to visit our community portal, where you can post general or training-related questions and receive answers to those questions. Lastly, please feel free to send an email with your questions or comments to elearning@rti.com. Again, thank you for watching and have a great day.